For some reason, my video stopped. Okay, so obviously we're going to put all this information where it belongs, and then we will very easily graph a function that fulfills the given conditions. Okay, so f prime of 0, they say it's 0. F prime of 2, they say it's 0. F prime of 4, let's say it's 0. Fine. So this is done. You don't have to cross it out like that. Between 0, the left-hand side of 0, the first derivative is positive. Fine. Or between 2 and 4. Fine. No problem. Done. The first derivative is negative between 0 and 2. Okay, fine. Or to the right of 4. Fine. Done. The second derivative is positive between 1 and 3. Fine. And the second derivative is negative to the left of 1 or to the right of 3. Done. Now it makes all sense. So let's come up with a graph. It all makes sense after we summarize it. Okay, so let's see. Obviously, when the function is the derivative is positive, the function has to be increasing. When it's negative, it has to be decreasing. So obviously, whatever you want to decide to put in here doesn't matter. It has to be a local max. Then this one has to be a local min, whatever you decide. That's the y value. It doesn't matter. Increasing and then decreasing, so this is a local max again. Local max, local min, local max. Fine. Now, the derivative, the second derivative changes sign, so the function has to be increasing. I'm sorry, has to be opening up, has to be opening down, or has to be opening up. That's not what I meant. Say one thing and I write something else. So when the second derivative is negative, the function does not hold water. And it makes sense. There's a local maxim here. So opening up, it must be a local min, and opening down, and it must be a local max, of course. Okay, so now we're ready. So at 0, somewhere for x equals 0, it doesn't matter where, the function it's opening down, and it reaches a local max, and it's increasing. Fine. Here's my local max. Increasing, opening down to a local max. It's going to start decreasing till a certain point at 1. This is the point of inflection at 1, IP, because it starts opening up and it's decreasing to whatever where there is a local min. So it's opening up till, so at 3, so this was 1, 2, 3, and 4. At 3, so at 2 it has a local min. At 3 it will have an inflection point. So this is 3 here. So it should have been, let me erase one of the pluses so you understand that this is at 3. It's the IP here. But I want to be more accurate and make sure that it's right under 3. So that another plus doesn't make any sense there. Okay, so there is an inflection point at 3, fine. And then it will have a maximum at 4, opening down. And then it continues to open down forever. So this is an example of a graph given the conditions. of critical numbers, sign of the derivative of the first derivative, sign of the second derivative, and we know what each piece is representing when it comes to the graph of the function. What would you like to see next?
We see a trig function.
Yes. Trig functions will always take a lot of time. Let's do it. We need to. There is no discussion there. Okay, here's a trig function. F of x equals cosine squared minus 2 sine x. And I'm happy that they restricted between 0 to 2 pi. Thank goodness. Okay, perfect. So I get my table going. Between 0 and 2 pi. So f prime of x, f of x, and the second derivative. Okay, I will start with finding the X intercepts and solving the trig equation. Let's see how we do that. So when f of x is 0, then cosine squared x minus 2 sine x will be 0. This is a trig equation. And we notice that it has both sine and cosine. We're going to change cosine. Anyone remembers what cosine squared equals to? And I'll get a sip of water before you say anything. What does cosine squared equal to in terms of sine?
Is it 1 minus sine squared?
Very good. Excellent. So this is 1 minus sine squared. So then the equation becomes 1 minus sine squared x minus 2 sine x equals 0. I will arrange it in descending order and at the same time multiply both sides by -1. Sine squared x plus 2 sine x minus 1 equals 0. So I'm thinking we have to find sine x. If we want a graph, we have to find the x intercepts. So we want to, I'm going to replace this because I want to put it in the calculator and see what solutions we get. I'm going to replace this by t, like t squared minus 2 plus 2t minus 1 equals 0. So I get -2 plus or minus 4 minus 4ac over 2a. So yeah, I get some weird solutions because I have the square root of 8, so minus b plus or minus b squared minus 4ac, so that's 8. So t will be -2 plus or minus, the square root of 8 is 2, the square root of 2 over 2. So the solutions will be -1 plus or minus the square root of 2. So I have no way of determining nice solutions for that. So I have to find sine x being, let me see, maybe they're not even possible. So sine x will be -1 minus the square root of 2. That's not possible because it cannot be more than 1 or less than -1. And the other one will be -1 plus the square root of 2, and this one works. Is sine x 1.41 minus 1 is 0.41. So it does have two solutions, one in the first quadrant and the other one in the second quadrant. And what they are, I have no clue. I have to put in the calculator and determine the sine inverse of that. and I want radians. Yes, I want radians. It is in radians. I had to check. Sine inverse of 0.41. It's 0.422 in the first quadrant. Sine to be 0.41, this is 1, so it's somewhere here. It's this angle and this angle. So the first solution is 0.422. So this is in radians, 0.422 radians. But we don't have to write it if it's just a number. We know it's radians. And this one has to be pi minus that. So pi minus the previous answer. So this one will be in radians, this second angle, 2.7719. Okay. As I said, it's a lot of work with these trig. Okay, so this will be the marker for the first quadrant, then pi, and then 3 pi over 2. So 0.422, this is 3 divided by 2, so this is definitely here. I'm just checking my 422, so this is 0. And the other one is in the second quadrant. This is 3, this is 2.7, that's correct. 2.719, it's here. So these are the x-intercepts. And we can also at the end check with the calculator, of course. So I do have to check, I have to plug in 0. Cosine 0 is 1, this is 0, so this will be 1. Cosine 2 pi is still 1, squared is still 1, and this is 0, so this is 1. I always have to determine the values at the endpoints. If they are infinities, which was this one example, but infinities or the endpoints of the closed interval. I need to determine those always. Okay, so that's it. That's it about the function. I'm done. And I only need now this first and the second. Let's see what mess we get in without those two. It is what it is. So f prime of x will be 2 cosine x times negative sine x and minus 2 cosine x. So I differentiated. Let's go back slowly. I differentiated cosine squared. So I have 2 cosine times the inner function prime, which is negative sine. I copied negative 2, and I differentiated sine, and that changes into cosine. Yes, I will rearrange it, removing those negatives, and etc. So I have negative 2 sine x cosine x minus 2 cosine x. Yes, that's nice. I will factor out negative 2 cosine x, and then I have sine x plus 1. That is nice. So I will be able very nicely to determine, that's what they did. They couldn't come up with a nice x intercept, but they came up with nice critical numbers. That's good. At least that. Thank you, whoever came up with it. So, of course, f prime will always be defined, but critical numbers will come from f prime being 0. And we have two options. Either cosine x is 0 or sine x is negative 1. And that is really nice, because cosine 0